Okay, this is further questions number 3 solution. We've got an inductor and a resistor in series with a ramp voltage of 600 millivolts per second. So this is quite an awkward one. Remember, it involves these partial fractions with quadratic factors. So it's going to be quite a long question. We'll try and simplify it at the start as much as we can with these units, but let's see how we go. So the first step is to write down what E is in S space, and that's going to be 600 millivolts, which is 0.6 volts over S squared, and ZS is going to be 3000, which is 3 kilo ohms, plus 6 times 10 to the minus 6 S. So now Ohm's law tells us that IS equals the voltage, which is 0.6 over S squared over 3000 plus 6 times 10 to the minus 6 S. Bringing the S squared down underneath, this gives us 0.6 over S squared into 3000 plus 6 times 10 to the minus 6 S. So that's going to give us our 3 factors, one involving S, one involving S squared, and one involving the bracket. So IS equals well, A over some term involving S plus B over some term involving S squared plus C over 3000 plus 6 times 10 to the minus 6 S. So now we have to cross multiply and equate numerators. So we get that 0.6 over S squared into 3000 plus 6 times 10 to the minus 6S equals A times S, 3000 plus 6 times 10 to the minus 6S plus B times the bracket plus C times S squared all over that denominator. And so we can actually equate the numerators. So this is all over the denominator, which is the same as the left-hand side. So now we can equate the left and the right-hand side numerators, and we get that 0.6 equals AS times the bracket, which is 3000 plus 6 times 10 to the minus 6S plus B 3000 plus 6 times 10 to the minus 6S plus CS squared. Now we have to multiply out and collect together terms involving S squared, terms involving S, and constants. $3,000 AS plus 6 times 10 to the minus 6 AS squared plus 3000 B plus 6 times 10 to the minus 6 BS plus CS squared. Collecting terms involving S squared and S and so on equals 6 times 10 to the minus 6a plus c s squared. Terms involving s, 6 times 10 to the minus 6b plus 3000a s plus 3000b. And now we can make up 3 equations as we did in the previous example. And so we get that 6 times 10 to the minus 6a plus c equals 0. Call that equation 1. We get that 6 times 10 to the minus 6b plus 3000a equals 0, equating coefficients of s, and finally 3000b equals 0.6, and that's equation 3. 3 equations, 3 unknowns, solved simultaneously. From equation 3 we can find b. Once we've got b, we can substitute that value for b in equation 2 to find a, and once we've got a, we can substitute that into equation 1 to find c. So if you want to have a go at that, the solutions are, we get that b equals 0.2 times 10 to the minus 3, a equals minus 0.4 times 10 to the minus 12, and c equals 0.24 times 10 to the minus 15. So very small numbers. 10 to the minus 12 pico, 10 to the minus 15, what's below pico? Femto. But anyway, let's see what happens when we put those numbers back into the original formula and tidy up. We get from is equals a over s plus b over s squared plus c over 3000 plus 6 times 10 to the minus 6s. The following, putting those values in. The first two we can transform, but the last one, if we divide every term in this fraction by 6 times 10 to the minus 6, that will give us transformation in terms of just s only. Which gives this, which to me doesn't look quite right actually. I was expecting this number here to be the same as this number here, which they're not. So I think I might have made a mistake somewhere further back. Perhaps you can find it. Anyway, I'll perhaps have a look at it later. But so if we carry on with this solution, we would get that IT equals, so negative 0.4 times 10 to the minus 12 plus 0.2 times 10 to the minus 3t plus 4 times 10 to the minus 11 e to the minus 0.5 times 10 to the 9 t. So again, we've got a 10 to the 9 up here. It's a huge number. And so this thing is going to exponential, any exponential effect is going to die away extremely quickly. If we have a look at this and autograph, we would see that it would reach its transient, go through its transient period extremely quickly and settle down to a steady current.